Hi everyone, in this lesson we're looking at function operations. So we have the sum function operation, the difference operation, division, and multiplication. And really it's not that difficult. I think what you just need is a lot of practice, so we're going to get right into it here. We have f of x is 2x squared and g of x is root x minus 2. All right, so for letter A, what we're going to do is we're going to replace x with negative x in the f function. So what I like to do is put a box wherever there's an x. So again, we're going to replace the x in the f function with what is inside the parentheses here. That's what's going to go inside our box. And then when we simplify that, we're going to get 2. A negative number squared is going to be positive x squared. So the first solution is 2x squared. Now for letter B, we're going to replace, in the g function, we're going to take 6 and we're going to replace x with 6 in the g function. So same idea. I'm going to put a box in the g function wherever I have an x. And then in that box, I'm going to replace what's in the parentheses here. So I have a 6 here, so a 6 is going to go in the box. And then I'm left with root 4, which is equal to 2. All right, now we have one of the operations. We have addition. So all we're being asked to do is add the f function to the g function. So the f function is 2x squared, and the g function is root x minus 2. And that's it. For letter D, we're doing the difference operation. So we're just going to subtract g from f. So our f function is 2x squared minus our g function, which is root x minus 2. And that's it for that one. For letter E now, we have multiplication of functions. So we have f, which is 2x squared, times the g function, which is root x minus 2. So you can write this the way I did the first time, or you could also write it like this. You don't really have to have the parentheses. All right, either one of those would be correct. I just think putting things in parentheses is a good habit. Now the next one is division. So we have the f function divided by the g function. The f function is 2x squared divided by the g function, which is root x minus 2. And that's it for letter F. And then the last one says, what is the domain of f divided by g of x? So what we want to do is we want to look at the denominator of this function and decide, well, this function is right here. This is our new function. And pretty much any number can go in there, but we do have a problem in the denominator because we can't have 0 in the denominator. That's one thing to worry about. And we also can't have a negative number under a radical. So the x minus 2 has to be greater than 0 because, well, the square root of 0 is just 0. That's not really a problem when you're talking about a radical, but having a 0 in the denominator is a problem, right? That's a big math error. We can't have that. And what's under the radical has to be greater than or equal to 0. So we know that we have to have it greater than or equal to because of the radical, and we have to have it greater than 0 because we can't have a 0 in the denominator. So now we just have a baby inequality to solve. So we know that x is going to be greater than 2. So the domain of that function would be 2 to infinity. Now don't worry, we're going to do a lot of domain type questions in this lesson because that's really one of the trickiest things for students to do. All right, we have some more practice here. You may want to try these on your own, and when you're ready, come back. We're going to replace x in the f function with negative x. So we're going to go ahead and do the box. So I wrote the f function, and I just put a box wherever I have x. And now I'm going to replace the x with negative x. and I'll simplify that. Now, you have a negative number. Anytime you have a negative number raised to an odd power, so we have a -1 to an odd power, it's going to stay negative. So when I simplify that first term, I'm going to have -3x cubed plus 1. And that is the solution for letter A. All right, moving on to the next one. We're going to replace x with 6 in the g function. So we want to write out the g function, and I'm going to put a box wherever I have an x. Inside the box, I'm going to replace with 6. Now I'll simplify that. And I get 1. All right, the next one, we're just going to add the two functions together. That's it. We don't have to do any further simplifying, so we're good. Next one, we're going to subtract f from g. This is where you have to use parentheses. You have to be careful here because we're subtracting the entire f function. So that means that that negative is going to be distributed to both terms. Go ahead and distribute that negative. Our final answer will be 2x minus 4 minus 3x cubed minus 1. Either of these, though, would be acceptable answers. So either the first way we wrote it or the second way we wrote it. Next one, we have multiplication. Now you can stop there if you want, or you could distribute the 2. 2 times 3x cubed is going to give me 6x cubed plus 2. And then that's all over x minus 4. So either of these, though, would be fine. This solution works, or if you distribute the 2. Letter F, we have f divided by g. So we have a fraction in the denominator, so whenever we have that, we're going to take our numerator and we're going to multiply by the reciprocal of the denominator. This is definitely not simplified in our first step. So this 3x cubed plus 1, think of it as over 1, times the reciprocal of the denominator. And we could write that as 3x cubed plus 1 times the quantity x minus 4 over 2. So that's one solution. Or if you want to, you could just distribute the top. You could use FOIL in the numerator, so we'll do that as well. The first term is going to be 3x to the 4th. And then the outer term is minus 12x cubed. Inner is x. And last is minus 4. All right, we have a good question here, letter G. What is the domain of f times g of x? So we are talking about this guy right here. We need to know the domain. So we need to decide whenever you're thinking about domain, what values of x would cause a problem for this function. So if you look at it, we have a fraction and we have a denominator. So what we would be worried about here is a 0 in the denominator. We don't have a radical. We don't have to worry about that. But having a 0 in the denominator breaks a math rule. So we know that x minus 4 cannot equal 0. So we would solve for x. So we know if we add 4 to both sides, x cannot equal 4. So it can be anything it wants, but it can't equal 4. So the domain is x cannot equal 4. If we're going to use interval notation, we would do negative to 4, not including 4, union with not including 4 to positive infinity. And I would prefer that you write things using interval notation. You got to get used to that. All right, some more to try here. We have an f function and a g function. We want to replace x with negative x in the f function. Now you don't have to use the boxes. I'm just using that since you're new to it. If you feel comfortable and you don't want to do that, That's not a problem at all, but I just find that this really helps a lot of students, so I'm going to do it that way. In the f function, x is our exponent, so that's where I put my box. So now I'm going to replace my x with negative x, so wherever I have my box, I just put in that value. So I'm putting in negative x. And we can't have a negative exponent in a solution that's not considered simplified, so we would end up with 3 over 4 to the x. Letter B, we have f divided by g. We have another domain question here. What is the domain of f of x divided by g of x? And again, in this function, we have to worry because we have a denominator, and our denominator cannot equal 0. So we know that x plus 2 does not equal 0. So x cannot equal negative 2. In interval notation, that would be negative infinity to negative 2, not including negative 2, union with negative 2 to positive infinity. All right, moving on to number 4, we have a log function for letter f, and the g of x is negative 5. So we're going to have some more practice with substituting x with negative x. So first we'll write out our f function, and we're going to replace x with a box. Inside the box is going to go the new value. We're replacing x with negative x. And there's really nothing more we can do to simplify that, so we're done with that one. Now we have f of x times g of x. We could also write that with the negative 5 in front. Or if you remember the power property, I call it leapfrog, you could take that negative 5 and you could make it the exponent. So any of these are acceptable solutions to 4b. Now, letter C says, what is the domain of f of negative x? So we want the domain of this guy right here. And what you need to remember about logs is that the domain of a log is going to be greater than 0. If we were to look at the graph of the parent function of a log, just as a reminder, here's the graph of the parent function of a log, and we have a vertical asymptote right here that happened at x equals 0. So for a log, the domain is greater than 0. That means that this part in here is going to be greater than 0. It has to be greater than 0. So we know that negative x plus 1 is greater than 0, and then we'll solve for x. So we get negative x is greater than negative 1. We're going to divide by a negative, so that means that our sign will change. We'll go from a greater than to a less than. And the domain then for f of negative x is going to be x less than 1. So that's our domain. If we put this in interval notation, we would do negative infinity to 1, not including 1. All right, so now we're going to take a look at function operations on graphs. Functions can be presented in multiple ways, including equations, data sets, and graphs. If you understand function notation, then the process for working with functions is the same no matter how the information is presented. So it says, use the graph below to determine each of the following, and we're going to assume integer answers. We're going to assume that everything falls right on an axis or a grid line. So the first letter A says g of 4. So in other words, if we put 4 into the g function, what's our output value? Well, here's 4 on the g function. Here's the coordinate for 4 on the g function. The output value, the value of y there, is 0. If we go to the f function and we input a value of 2, we'll do that in blue. Here's the f function. We input a value of 2. At x equals 2, the output value for f is at 3. Letter C is asking for g of 0, so back to the g function. When we go to x equals 0 on the g function, the y value is -4. Back to the f function. If I put -6 into my f function, I'm going to be right here on my f function. My output value is at 2. Letter E says, if f of x equals 0, what is x? So in other words, on the f graph, if the output value is 0, in other words, it's when y is 0, what is x? So here's our f function, right? When y is 0, right here we have a point. On this f function, y is equal to 0, so in that case, x is -1. Now, on the g function, when y is equal to 0, this guy right here, when y is equal to 0, what is x? So when y is equal to 0 on the g function, we have it here, and we also have it here. So that's happening at -4, and it's also happening at +4. Letter G says, if f of x equals 1, what is x? So we're going to go to the f function and we're going to see the output value is 1. Here's the output value is 1. What's x? X is 0. Going back to the g function for h, if the output value of the g function is -4, then what is x? So that's happening right here. So that means x is equal to 0. All right, for letter I, we're looking to find the y value when f is -1, y is equal to 0, and when g is -1, the output value is -3. So we have 0 plus -3, so that gives us -3. G of -6, so that would be this point right here. Right, this is -6. So the output value there is 2. Minus the f of -6 value. So if we go to the f function and we go to -6, oh, it's at the same place right here. It's at 2. So we get 0. Hopefully you're starting to get the hang of this a little bit. F of 1, if we put 1 into the f function, we get a point right here, that's at 2, times g of -2. If we go to g and we go to -2, we're going to be right here. G of -2 gives me a value of -2. So that gives me -4. And the last one, g of 6. So if we go to our graph, we go to 6, that's going to be right here. The height of the function right there is right at 2. Divided by f of -1. So we go to our f function, we go to -1. We can see it's happening right at 0. So we put 0 in the denominator, and anytime we have 0 in the denominator, we know that our function is undefined. All right, that was function operations on graphs. And now we'll do function composition. So just when you were starting to feel kind of good about these function operations, we're going to come along and do some composition. Now you want to be really careful and make sure you're awake for this part of the lesson. We're talking about something very different than multiplication. And students often get confused because this kind of looks like a multiplication symbol. If I said f times g, that does not mean the same thing as f composed with g. All right? So if I say f composed with g, I mean take the g function and input it into f. If I say g composed with f, I mean take the f function and put it into the g function. So whatever letter is first is kind of like the lead function. All right, so let's try practicing some of these. So we have f composed with g. In other words, we're going to input the g function into the f function. So just like we did earlier in the lesson, I'm going to replace x with a box in the f function. Now I'm going to replace that x with the entire g function. So this whole thing is going to go in this box. And now we'll simplify that. Whenever you have a square root squared, it undoes that square root, so we end up with 2 times x minus 2. And if we distribute the 2, we get 2x minus 4. Now the next one, g is first. G composed with f. So in other words, f is going to be input into the g function. So we're going to write our g function, and we're going to put a box wherever there's an x. And now what we're going to do is we're going to replace the box with the entire f function. And now we'll simplify that. Really, all we can do is just take away the box here. All right, there are two to try here. Number 2, A and B. I would suggest trying those on your own and come back when you're ready. We have the f composed with g. So g is input into the f function. Right, and I'm going to write my f function, and I'm going to put a box wherever I have an x. Inside the box is going to go the g function. Clean that up a little bit here. We have 3. 2 squared is 4. Leave that as x minus 4 squared. And 3 times 4 gives me 12 over x minus 4 squared plus 1. The next one is g composed with f. Write the g function and replace x with a box. Now we will put the f function in the box. We'll clean that up. 3x squared plus 1 minus 4, that gives us minus 3. All right, almost done. Show functions are inverses using composition. All right, well, I say recall, hopefully remember. The word inverse refers to the opposite of another operation. You can show that two functions are inverses of each other using composition. If f of g of x equals x, and g of f of x equals x, then the two functions are inverses. So let's practice that. First, we want to find f of g of x. So that means we're taking f and we're inputting in the g function. Our f function is 4x minus 2, so I'm going to have a 4, a box, minus 2. Inside the box, I'm going to put my g function. When I simplify that, the 4's will cancel. So I get x plus 2 minus 2. That gives me x. Okay, great. So we got that guy. Now we're going to do g of f of x. In other words, we have g, and we're going to input the f function into it. We're going to write the g function, and we're going to replace x with the box. Inside the box, we'll put the f function. And now we'll simplify. In the numerator, we have 4x minus 2 plus 2, so that's 4x over 4. And then the 4's will cancel, and we get x. So we have shown that f of x and g of x are inverses of each other. Right? Composition is really the trickiest one. Hopefully you felt pretty good about this lesson. Lots of practice. Thanks for watching to the end. Have a great day.